Calibria and Sentio have a very handy tool to navigate across of the calibration substrate. Actually, across the entire calibration standards, it doesn't matter if they're embedded on the off-wafer calibration substrate or embedded on the wafer. We call it Substrate Navigator. And Substrate Navigator displays you the map of calibration standards. They are color-coded. We use a gold color for transmission lines, so like long transmission lines or through elements. We use green color for load or match calibration standards, red color for short calibration standards, and blue color for the open. It's very easy to navigate, so you just look at the map here, which is very similar to a wafer map of your devices under test embedded on the wafer. You see immediately which standard is available and what is the standard conditions and how the standards are used for the calibration or calibration verification processes. What I would like to demonstrate here is the intelligence built in the Sentio in terms of the tracking of number of touchdowns. So Sentio tracks the number of touchdowns of every element. That is why when we teach Sentio for allocation of calibration substrate, we also define the serial number of a particular calibration substrate. And Sentio has a database where every time when Sentio moves the chuck to a given calibration substrate and a given selected standard from this calibration substrate, we take a record of a touchdown. So after the maximum number of touchdowns is achieved, Sentio automatically selects another standard of the same kind from the all available elements. And operator doesn't really need to think about it, which standard can be used as the next, because this is all executed automatically. I prepared here a short demo for you where you can see that our through standard, which we use for the calibration, and those standards which are selected for the calibration marked by this red circle here. So this is the through, this is the load, this is the short, and this is the open standard which will be used to execute the calibration process. And the lifetime of the through standard is kind of at the very end. We display the lifetime of the calibration standard in a similar way as we all know from our mobile devices when the battery runs out of juice. So you see the very similar pictogram on the screen of your mobile device. So actually this is exactly the same concept that we use for you. It's nothing new, it's very familiar for your daily use. So we see that the juice of our through standard is almost over. It's on the very end. We can always double check what is the current situation of the standard. So we see that the maximum number of touchdowns was set up for this standard as an example, the 7. So we already use it for probing 6 times, means that there is only 1 touchdown left. So let us use this very last touchdown for the calibration process and see what happens after that. So remember, one more time, we go back to the map of our calibration standard, and we will start our calibration process with using this through standard as our calibration element, and it will be used for the last time of its life. So we execute the calibration process. We move to this already used, and you see it's scratched and actually not of a good quality. And right after we did the measurements of this calibration standard, Sentio realized that that was the last touchdown of this calibration standard. So all the life is gone, and we automatically moved to the next standard from the line, which means that next time when we will execute the calibration process, this standard will not be used anymore, and the next standard will be selected. So, and now the process is executed as normal. So we go to the load standard, open standard, and short standard, and so on.